Hello and welcome to week 2. We're going to have a wee look right now at this new file, which should all be available on your blackboards as of this week. You didn't have it last week because we're cruel and unusual in the way we deliver information. So first thing you'll notice is there's a lot more detail on this drawing compared to the pulley facts document. Remember, we're sort of looking at a narrative with this project, and that narrative should reflect the real world where, you get the information trickled to you. You don't necessarily get it all at once, and you're often asked to start before you really know what you're actually doing. So the second thing you'll probably notice is that most of the dimensions we used last week are actually wrong once we start to look at a little bit more information on here. We can see things like the thickness of P05, which we did, is 2.5 mil, when in my last tutorial I set it to 2 mil. Now, I'm not going to show you every single difference. A large part of this assignment is your ability to read these drawings, interpret what, eventually becomes pretty complex information where you have to make inferred dimensions by comparing the way parts sit. A good way to do that is using this section view here. You can look at how parts interact, and you might say, well, I don't know what the size of this hole on my formed bracket is, this section here, but I do know the size of my bushing, and I can see that bushing is passing through that bracket. So, that is the intent of this assignment, for you to really critically look at a set of drawings and try and pull all the information you can from there as accurately as possible. Getting on with it, we're going to have a look at P04 formed bracket. This is a sheet metal part, but it's quite different to any sheet metal part we've done so far. It's got bends to it. So let's jump into SolidWorks and we will have a look at how we can model P04. I'm going to jump across to SolidWorks Student Edition. I'll create a file, new part, hit OK. And I'm going to save this as P04 formed bracket. So let's do that, P04, okay. Come to our document properties. You should be getting pretty familiar with that area now. And under property name, we will add a description. And that description is formed bracket. Hit OK. And I'm going to come into my front plane. I'm going to create a sketch. And this sketch is going to be like I am looking on at this front face of my formed bracket. So let's create a corner rectangle. And I'll just make that like so. And I'm going to use that as my pulley shape across the top. But I want to ignore this bottom line. The easiest way to tell a feature to ignore a line in your sketch is to turn that line into construction geometry. I can do that using this options box here. So I'll turn that into construction. We can see now it's dotted. It will get ignored by any feature we use. I want to lock that down because it's floating in space, so I'll select that bottom line. I'm going to select my origin, and I'm going to place a midpoint relation between those two items. Now I want to put some dimensions on. I want it to be 25 mil across and a magical unknown dimension high. And once we extrude it, it will then be 25 millimeters deep. The other bit of information I'm getting there is this 3 mil thickness. So I'll put that 25 mil across. Then for now, because I don't really know my dimension, I'm going to just have to drag that around until I start to see, drag up is what I should be doing. It's already dimensioned widthwise, so I can't really change that until I think it looks similar dimensions to this bracket here. And I think that looks a little bit tall, but I might just put a dimension on for now anyway, like so. And I could probably drop that back a little bit. Oh, actually, it's probably not too bad. I might even bump it up to 35 now that I'm imagining how it looks in 3D. Like so. And now I'm going to use the sheet metal feature again. I can see it just here. If you can't see it there, turn it on by right-clicking in the blank area of your toolbar and selecting sheet metal. I'm going to use the base flange tab. Really, if it's the first sheet metal component you're making in a part, it's going to be the only option available to you, is base flange tab. Now, the first issue I can see is it's creating metal on the outside of my sketch. If I look at the way I've dimensioned this, all that material should be to the inside. So I'm going to select reverse direction, and now we can see it's on the inside. I also want to make sure the thickness is correct. It should be 3 millimeters thick in steel. And for the direction, I'm going to change blind to mid-plane. That means that now it's coming out from the center, which keeps my origin nice and central to the part. And I'm going to set the distance to 25. And hit OK. We'll let that load, and then once that's loaded, we'll hit save. And that's looking pretty good, but the next thing I want to do is add this little rounded bottom to this shape. So I'll come back across, I'll jump into my side view there, and I'm going to draw on the right plane. I'll make a sketch, and then I'm going to draw a line in from the side. I want to make sure that line's vertical. And then I'll come back across to that starting point, and I'm going to pull an arc out from that starting point, drop that on the opposite side, and then pull it out and across like so. And what this is going to be used for is to cut away any material below that sketch so that we can remove the bottom of this arc and make it look like a nice, lovely, rounded bottom U-bracket. Now, I can see that bottom's not touching. I'm going to put a tangent dimension on there. We went over that in a lot more detail in class about, what that does to the geometry and why we want that. And now that's looking pretty nice and good. It looks like we got a good bit of tangency going on there. The only thing that's still underdefined is the length of these lines. Now, we don't really care what they are. We just want them to be longer than... we just want them to fall outside of this end line. The reason for that being is, we could probably get away without them, but SolidWorks can get confused, and we don't want SolidWorks to try and continue cutting into that part. So by placing this line through, we just guarantee that it's going to cut down through the bottom and not start chopping into the top above these lines. So to fully define them, I don't care what the length is, so I'm just going to select both lines and any other line traveling in the same direction and say that they're equal. As long as these lines are bigger than 0 millimeters long, they're going to be doing the job we want them to do. So that's very good. Sketch is done. We can come to our features. We can use extrude cut. And the setting we're going to use for this extrude cut is through all both. Now, if I use the center scroll wheel to orbit around, I can see that's cutting through in both directions. But what I want to look out for is this arrow, which is right now telling me that it's going to cut everything above the line. That's the opposite of what we want. So let's come into our settings and choose flip side to cut. We'll see that arrow is now facing down, meaning we're going to cut away everything below that line. We'll hit OK. And now we should have a nice, well-shaped bracket that only needs a couple of holes added to it. Now, for the sake of this assignment, you could very easily just sketch some circles on your right plane and top plane, whatever you feel is appropriate, and cut those through as a through cut to get these 3 holes. We're going to use a slightly different feature. It's not compulsory. It won't lose you any marks if you don't use it on the assignment, but it's great to have a play with and understand, and it's called the Hole Wizard. So I'll select Hole Wizard. It'll take a little bit to load because it's a fairly involved feature. And you can see I've got all kinds of settings. I'll get you to have a play around with those in your own time and just figure out what they all do. They're pretty excellent and they're super useful, especially things like the counterbore hole where you just want to hide the head of a screw, or things like the straight tap where you want to specify a threaded hole or something like that to an engineer that might be creating the part for you. Under standard, we'll just select ISO. You'll probably find by default it's set to ANSI inch. We want to just use ISO when possible. And under type, I'm going to select drill sizes. And under hole specifications, I'm going to select, for now, 13 millimeters. End condition through all is good. I want to cut through everything. And so that means now I'm doing a straight hole, 13 millimeters in diameter through everything. But I need to place that hole. So I'm going to come up to the position tab under the hole wizard and choose 3D sketch. And that has now brought me into this 3D sketch where I can start placing holes on the part. And you can see that that's actually previewing where the holes are going to lie. I want to place one on the inside face at the center of that arc. So what I've done there is I've just hovered on the arc. That makes the center point of that arc appear. Once that center point's appeared, I can actually just click and drop my hole onto there, and it's already fully defined. It's made itself coincident to that center point because that's what I dropped it on. So I'll hit OK, and now I've got two awesome little 13 mil holes, and you know, it's quite a complicated way to do a hole, but it's got a lot of strength when we go to doing drawings later in the amount of information that we've just embedded in those two holes. That, you know, we've created that nice extra layer of metadata within the software. Now I want to repeat that process to place a hole at the top, so I'll come to the hole wizard. I think the hole at the top is going to be a little bit smaller. It looks smaller for sure. You know, we can see it's actually got to fit this part, so let's have a look. That's a 10 millimeter part, so let's assume it's a 10 millimeter hole. We can change our hole size here to 10 millimeters, and under position, I'll go 3D sketch. And I'm just going to drop that on the top there. Now I've got an issue in that that's not fully defined. It's not even really centered. So I might have to use some sketch geometry to help center that part. And the geometry I'm going to add in is I'll draw a center line from the midpoint of the far two ends. And then I will draw a width center line across the two middle points of that. Now I should be able to click and drag that point and drop it on that midpoint, and it should become fully defined. I'm going to delete this little angled line because that's sort of, I don't need it. It's just coincidental of my other processes. So we're still under defined. So let's have a click and a drag and we'll see what's moving. All right. You know, it's still moving around. So rather than just trying to drag and drop, it didn't look like SolidWorks knew what I was going for. I'll select one of the lines. I will select the point that defines the center of my hole, and I will choose a midpoint relation between the two. Now that should be fully defined. We can close our sketch. And we can see we've got that through all drilled hole. Now this bit's pretty magic. The reason we've used sheet metal is that we would not create that 3D. We would cut it out of a flat piece of metal and then use a press or a line bender to bend that piece up. A brake press, I should say, to bend that piece up. And if I want to see the flat pattern that I need to cut, SolidWorks can use all that information we've just given it through our base flange and sheet metal feature to show us what the flat version looks like. So I can preview that by right-clicking my part and choosing flatten. And SolidWorks will think, it'll crunch the numbers, it'll get, you know, it knows how much the metal stretches when we bend it, and it gives us a very accurate flat pattern sheet metal feature. If I want to go back, I just close the flatten by clicking this button in the top right corner. Very good, so save your part and move on. Excellent.